This is Chad Morgan, Principal Engineer with TE Connectivity. I work for the Circuits and Design Group within the Datacom business unit. And I'm just coming to you today to give you a brief update on a paper that we gave at DesignCon 2012. And the paper was called A Comparison of 25 Gigabit per Second NRZ and PAM4 Modulation in Legacy and Premium Backplane Channels. I gave this paper in partnership with Adam Healy of LSI. And just to summarize the paper and what it was about, we talked about a popular topic right now, which is how to get 25 gigabits per second to run accurately across backplane lengths of up to a meter. And the big question, the big debate that's out there right now is, can that be done with 25 gigabit per second NRZ, or which we know it can be done, but it requires premium printed circuit board materials and premium connectors, such as TE Connectivity Strata Whisper connector. But some people in the standards bodies, such as the IEEE 100 gigabit Ethernet workforce or task group, have proposed that perhaps 25 gigabit could be done using 12.5 gigabaud PAM4 signaling, using backplane systems that have already been built for 10 gigabits per second. In other words, using legacy printed circuit board materials and legacy connectors. So the presentation that Adam and I gave, the goal was to look at both legacy and premium backplane environments and determine what signaling schemes worked for each one. What you had to do if you were going to go the 25 gig NRZ route, and what you needed to do if you're going to go the 12.5 gigabaud PAM4 route. So TE Connectivity was able to provide all of the channel data, both 3/4 of a meter and 1 meter channels, using both a premium connector, which is Strata Whisper, and what we call a legacy 10 gig connector, which is CPAC Tin Man. And we provided those channels in two different dielectric materials. We provided it in what we call an improved FR4, which is what's pretty much employed out there for 10 gigabits per second. And we were also able to provide that in Panasonic Nitron 6, which would be a lower loss, higher quality material. Adam then took those channels and, with LSI's simulation tool, was able to run a PAM4 DSP architecture and an NRZ analog architecture and look at the results. And there's a large paper and presentation there, but to summarize it, what we found is that to run NRZ at 25 gigabaud across the meter, you really need to dot your I's and cross your T's. You need to use premium dielectric materials for your printed circuit boards, and a connector such as Strata Whisper with its low crosstalk and low reflections is required. On the other hand, if you want to try 12.5 gigabaud PAM4, then you have some flexibility with the printed circuit boards. You might be able to go with an improved FR4, but you still need to use a premium connector such as Strata Whisper with low crosstalk and low reflections. Turns out the reflections are very problematic. The decision feedback equalizer in the circuit has a hard time recovering and correcting for long time delay reflections, and crosstalk is also an issue. So a connector such as Strata Whisper really helps things whether you want to do PAM4 or NRZ. So that's what we presented. It seems to be well received. It's yet to be determined how the standards groups are going to, what decision they're going to make as far as PAM4 versus NRZ. But at the end of the day, right now, at 25 gigabits per second, it appears as though Strata Whisper offers a good level of performance to help make those links work. So if you'd like to find out more about that paper, or download it, or potentially more about Strata Whisper from TE Connectivity, you can visit the DesignCon 2012 trade show landing page, which, if all goes well, is being shown to you now. Thank you for your time, and look forward to hearing from you.